Right, can everyone hear me? Excellent. I'll try and keep this as short as possible. Quick show of hands, how many people actually understand how the SSL negotiation works? And for client certificates? Right, okay, I'll quickly do this bit then. So the proposal was, many years ago, that an organisation has to work with a lot of external third parties. So this was the wish list. All developers should have a level playing field when it comes to developing applications, whether you're a third party or an internal person. That's quite a big ask for most organisations. So it also had to be open source first, because, hey, publicly funded. All developers have to be able to work seamlessly across all projects. So if you end on a project one day, you go to another project, bear in mind there's about 160 of these at any one time, you have to be able to pick up and carry on with that person's code, release, develop, everything. So we had to have source control, documentation, workflow support, basically everything you need to work. Forgive me, I skip over a few things. So it's another one of these moon on the stick organizations again. So SSL negotiation, quick run over. You got someone says, hello, I want to talk to you over SSL. The server comes back and says, okay, I am this person, gives you a certificate. And then it might optionally say, oh, by the way, who are you? At that stage, you can optionally give them a client certificate. You both validate. And if you both agree that you are who you say you are, you open up a connection. And that should cover it for now. Any deeper and we start getting into maths. So we had to build every single tool with SSL termination. Each certificate contained who you were, what type of person you were, and that was then used to determine what services you had access to. So when you're building something simple like Jenkins, and you're logging in with the username and password, that's nice and straightforward. You can, I don't know, integrate with AD. As soon as you come into the world of scraping stuff from an SSL client set, by the way, what year do you think this is? Just out of curiosity. I mean, the year we're trying to do this. It's about 2008, just to give you some background. So we have a user with a client cert, terminates with Apache. Apache does all of the SSL negotiation, termination, parses all the headers that come from SSL, pass them through to Jenkins, and of course, Jenkins, like everything else, has a nice open source framework, and you write a module that allows you to then parse the headers, and you write your own login system for Jenkins. Now, part of the certificate framework to prove whether or not a certificate is valid is a thing called a certificate revocation list. This is the certificate of the issuer maintains a list of things that are valid, i.e. any certificate that's gone out, and anything that's not valid, it publishes a list. And that list is optionally consumable by anyone using the system. So that means a certificate with a valid lifespan of a year will still work if someone's not consuming the certificate revocation list. Now, there's a balance between issuing a certificate for a long period of time and therefore failing very, very open, or making sure that the certificate revocation lists are incredibly up to date. Now, as this was a public organisation, they tended to fail open quite a lot. So unless you got fired for cause, generally the CRLs are fairly out of date. But the CRLs are pulled down from every single Apache on the system. So there's a script which pulls down the CRLs, and this is before Apache could restart, could do anything without a restart. So of course, restarts Apache, hopefully without breaking all the sessions of people connected. And then that allows you to keep your authorization framework up to date. Sorry, authentication, authorization, always get those two confused. And then you have, of course, Hudson and Jenkins as a service, and that also is using client certificates. It's not just people, this is every single service device also has a client cert, and that is used to talk to Subversion through, yet again, more Apache magic with headers. Now this is basically background. Now, I'm going to skip over this quickly, but the period of time is support 400 developers across 160 development teams and build an AWS CMDB and deployment platform, which is the bit we're going to come onto next. I'm keeping this a bit brief because I'm sure all of you guys want to go to beer and pizza. So, once we had this framework, it was like, well, there's this thing called ADIS come along. The year is about 2010, 2010, 2011. And that means we need to have a new root certificate, because having the same chain of trust for your cloud as for your internal staff and external staff, of course, and every other person in the organization. So there are about 20,000 staff, each with their own client certificate, 400 developers, internal and external, with their client certificates, and about 3,000 machine certificates. So new root certificate, new chain of trust, new intermediate certificate, so we could issue stuff. And we now had to expire certificates every 30 days. All the certificates must auto-update. Anyone know about trust stores? What a trust store is? So a trust store is a list of the certificates that you as a client trust. So do you trust Google? Yes or no? Do you trust our self-signed certs? Yes or no? Now this is a completely independent self-signed set of chains, because these are not supposed to be public. These are supposed to be consumed by people and machines. So we have to generate serials and trust stores. And just to rub salt in the wound, this must be completely non-interactive. Must be completely automated. So for those of you who haven't deployed SSL certificates before, you generate a private key and a CSR. A CSR is a certificate signing request. Apologies if this feels a bit like my first SSL, but the certificate signing request is a public part, which you send off to something, it signs it, and therefore becomes the issuer of your certificate, and returns you a version. Now there's two different versions of certificates. There's a binary format and a text format. The binary format is for awkward things like Java. Java has to consume a binary format. And the string one's for pretty much everybody else who isn't Java. You have to put the certificates on the instance or the service, and it has to be in a predictable place, because there's 160 development teams, all of which consuming this stuff without actually understanding what SSL is. So all has to hit the same place. Plus, of course, in our wisdom, we gave all developers the ability to run arbitrary scripts during startup. So we essentially injected into RC0 to 5 any script the developer liked that was called RC0.5, and they could run it in any order they liked. So we told them we ran all the certificate stuff at 50, and if they went from 0 to 49, that ran before, and 51 onwards ran after. The instance must be self-healing, so if you put a bullet in any of these, then they have to come up and still work and function just as they were before. Trust stores must not expire, because if a trust store expires, SSL negotiation fails. Very awkward on live instances. And the CRLs must be kept up to date. By that means, if the trust store the certificate revocation list, or things you don't trust, haven't been updated in the last 24 hours, you have to kill the instance and keep it killed, which is fun when it happens in production. So you have a few touch points for this particular thing. You have Amazon accounts, about, 200, 300 Amazon accounts. One management account. I'll come back to what these little red blocks are in a minute. Some certificate of authority, some bunch of templates, CloudFormation templates in this particular case, some continuous integration system, some source control. Now, all of these little things have to somehow be welded together so that we satisfy all those previous constraints. So we decided to build a CMDB, not out of choice, you understand, but just because of the situation we're in. So when you're building a piece of software on Amazon, you have a choice. You can either push your code to something, or you can bake it into something. In our particular case, the main constraints were it must self-heal and it must update. So what we did is we had this thing, an AMI as a unit of deployment. Now that AMI could be produced by anyone, and what we did is during the process of creating it, we then found that we could, I don't know, mount it as a volume on an instance, as a flat file system, maybe push a certificate onto it and a bunch of management scripts, and then turn that into an AMI and push it somewhere. So that meant that our certificate management system here could sit in one secure zone. This thing here was called a bakery. because it baits stuff. So what that did is it had a schedule where it took an AMI from someone's account, and we, of course, had to track it and index it, pull that AMI across centrally, mount it, inject a brand new certificate, turn it into an AMI, pick it up, and throw it into the CloudFormation template in that account and roll it out through the auto-scaling groups, which meant that essentially you didn't change anything. All auto-scaling groups had to be a minimum of about 3 just to support this, and it also meant we could run Chaos Monkey. Now, if any of you run Chaos Monkey on any environments, you know that that's a great test of this sort of process. This CMDB here took about 1.5 years to write and get correct. But obviously, because everything has to use SSL, there is a few other little wrinkles. So each of these accounts here was completely fine. That was all independent because the customer controlled this. The code repo, again, we've already covered this with the Jenkins. The problem is that customers want to see into their accounts. They actually want to be able to see what they're doing in there. So obviously, off the side of the CMDB, you have to build an authorization platform. You have to be able to link a product owner to their account and a developer to an account. Now remember, they can move around a lot. That means that the product owner has to be able to assign a developer to account, which means they have to then basically have a lookup service for a certificate. So off the back of the CMDB is also something to look up which certificate belongs to which person. So you can then add them to account. So you can then use STS to log a customer in when they go to your portal to their account, which is great because that means that you go onto a custom endpoint and then you issue a redirect to a particular account. Now that's still a man-in-the-middle attack even now. So of course you have to do a little bit of monkeying around with your what is essentially a cross-site scripting attack or cross-site request forgery attack. Great fun if you're trying to debug it in Firefox with something like NoScript, by the way. It registers as an attack. So just as a quick summary, we have now got client certificates here for every single machine on a cloud chain of trust. We have a system of putting the certificate in, and then we also have a certificate management system, which is, I forgot to mention CRLs. So we have an account here. This account has to talk to this system. Now, this system is a secure system. So, unfortunately, didn't have time to do the slide because I only came up with this talk last Thursday, but there is a S3 bucket in the middle of here. The S3 bucket is web-enabled, and that contains an up-to-date pushed list of all of the CRLs. Now, that worked great until you realize that there's, 200 accounts, each of which with their machines. That's when CloudFront becomes incredibly, incredibly vital. The other thing that when CloudFront ran out of juice, there were some lovely things called Zeus load balancers, Zeus traffic managers. Those ended up being the point which we had to fire all of the CRL requests at just to keep them up to date because they had inbuilt caching and could take the load. If you've ever done secure load balancing before, so i.e. terminating SSL, we tried it and it broke. So with all of the SSL requests coming in, it's not the CRLs, but just all the SSL, then we tried elliptical curve Diffie-Hellman, or the elliptical curve, and all of a sudden everything worked. So just a little bit of advice, if you're doing SSL at scale, do try and use the elliptical curve ones for termination. And with the CRLs, we eventually replaced it with OCSP, which is certificate pinning, essentially a query-based system rather than a push CRL system.